Good evening. My name is Chitirala. I'm from Milford, Connecticut, and I'm an 8th grade student from Engineering and Science University Magnet School. My product is called the Flying Ozone Filter, which filters out chlorine atoms from the ozone layer. At 5 to 15 kilometers altitude, the ozone layer is slowly becoming depleted by the emission of chlorofluorocarbons, or more commonly known as CFCs. As these CFCs are broken down by the ultraviolet radiation from the sun and release chlorine atoms, these chlorine atoms bond with ozone atoms and release the oxygen from the ozone atoms to form oxygen molecules, repeating the cycle until the ozone layer becomes oxygen molecules, which don't prevent the ultraviolet radiation from being emitted into the surface. As a result, this filter will prevent the chlorine from depleting the ozone layer and keeping the ozone layer intact. This chlorine filter will act like an oxygen concentrator, but instead of filtering out nitrogen, it'll filter out chlorine. And this filter will as the filter will filter out chlorine atoms, the ozone layer will be reproduced when oxygen molecules break into two oxygen atoms and bond with other oxygen molecules to form ozone molecules. This product functions when air and chlorine go through the gross particle filter through the sodium bed, which halfway contains metallic sodium, and hot water gets injected into the sodium bed, reacting with the sodium, and the chlorine atoms will then be able to react with the sodium atoms to form sodium chloride. The sodium chloride and the air go through the compressor, which compresses the air, through the double solenoid valve, which goes through each one of the sieve beds, and each sieve bed contains zeolite A molecular sieves, which are aluminosilicate catalysts that can absorb polar molecules. And surprisingly, sodium chloride is also a polar molecule because of its ionic bonding with the chlorine and sodium. And sodium chloride molecules get trapped in the zeolites, and the rest of the air goes through a pressurized canal and out into the atmosphere. Once the sieve bed is full of the sodium chloride, the double solenoid valve switches directions into the other sieve bed, and the original sieve bed releases the sodium chloride into the outer shell of the filter. This product is not really marketed towards a general public, but it's more targeted towards aircraft manufacturers, because aircraft manufacturers can apply this, or they can affix this chlorine filter to the bottoms of the wings of airplanes and allow the airplane, which generally flies in the same area as the depleted ozone layer, to filter out the chlorine from the ozone layer. And previous issues I had with this product, well, the making of this product, were that I had to keep the sodium atoms in the sodium bed stable, but it can't react with any of the surrounding air already and with the surrounding case. So as a result, I made it stay in its metallic form and be sprayed with hot water whenever the chlorine air goes through the sodium bed. The size of this product would be a little smaller than the Boeing 777's General Electric GE90 engine. The cost of this product will include the prices of each individual material used for the production of the ozone filter, totaling up to $510,255.86. This product will prevent an imminent danger from the ultraviolet radiation from the sun, and make the atmosphere and the surface a better and safer place. Thank you.